I'm Tom Roellig. I'm the Deputy Project Scientist for SOFIA. I also have a couple other roles I have at SOFIA as well, but for the time being, that's what I am. And I'm going to talk just a little bit before you get on the plane, talk a little bit more about the science that SOFIA is going to do and did do. I'll show you some of the results we've got. I'll only be able to show you some of the results. We've been flying all summer long, and we've taken a lot of very, very good scientific data. Unfortunately, most of that data right now is still being analyzed, and it is also under the purview of the principal investigators who actually proposed to do that work. So they get a certain period of time, like anything else in science, where they get exclusive access to that data, and then afterwards goes out to the general public, and anyone in this room, anyone anywhere can go online and pick it up and do what they like with it. So let me just talk, first of all, we're just going to talk very little bit about the astronomical science from SOFIA. I'll show you a little bit of some recent results, and I'll talk very briefly beforehand what you're going to be seeing on the airplane. So Pam Markham at the beginning of your tours here today talked a little bit about why we do infrared astronomy. I won't go that much into it. As you know, there's really three big reasons why infrared is particularly good for doing astronomy. For things that are seen very far away, the light due to the Big Bang is redshifted into longer wavelengths. And so starlight, for example, we don't see invisible light when it's far away. We see it in the infrared. And of course, when you're looking far away, you're looking back into time too, because it took the light so long to get here. So you're looking at very old and far away things. Cooler objects, such as stars in the process of being formed have most of their radiation actually coming out in the infrared. And plus, as Pam mentioned, that we have the ability to penetrate the clouds of obscuring dust in the universe, which are quite prevalent. And as we joke, we just, in the infrared, we observe the old, the cold, and the dirty. We do that very well. And in fact, infrared is very, very popular. If you actually look at the James Webb Space Telescope that's going to be replacing the Hubble, that's an infrared telescope. That's got a lot of advantages. Now that we have the technology that can do that we can use to, apologize for this flickering like this. I will not spend a lot of time going through here, but in SOFIA there are some particular areas that SOFIA is going to be good for with the size of its telescope, with its ability to fly above almost all of the Earth's atmosphere, especially the water vapor in the atmosphere. And a couple things that we've looked at so far. We've looked at this area around the black hole in the center of our Milky Way. There's about a 3 million mass black hole right in the center of our galaxy. And we've also looked at the outskirts of the solar system, presence of moons. I'm going to show you some data that we've gotten on Pluto, the minor planet Pluto. It was demoted from a planet. And SOFIA particularly is good at some things, and particularly compared to something like Hubble. We can see objects that are much cooler than normal stars, than the sun, stars and planets forming. You can see stuff behind the dust clouds. We have an infrared telescope in space right now, a Spitzer Space Telescope, but it's smaller. Its mirror is smaller than SOFIA's, and as a result, it can't see things with as close a detail as SOFIA can. So, and also, we've got plenty of instruments. I'm going to show you right now the instruments we've already got available to us. And in fact, we've actually, and NASA just selected, or not selected, but accepted a number of proposals for a next generation of instruments for SOFIA. We'll select the ones that we think are the best. They'll get funded, and so we'll get some additional instruments as well. As Pam mentioned earlier, SOFIA is much like a space telescope, but it comes home every night. And that means that if you've got a broken instrument, you can fix it if you rapidly set it back up. And you can also get new instruments on board. Now, the Hubble was able to put new instruments on, but it was at a tremendous cost. A space shuttle launch is, many hundreds of millions of dollars, and swapping an instrument out of SOFIA is considerably cheaper. And then, as you've also been told, that we can actually fly other guests, like teachers and journalists on board. That's has already happened, and will continue to happen as we fly SOFIA. So, there's basically 4 major science themes for SOFIA. We are going to be interested in galaxies and our own galactic center. We'll be interested in the interstellar medium, the space between the stars and the Milky Way, because that's where new stars form. We'll be interested in the formation of stars and planets, and then our own solar system. And we've got a number of instruments that we've selected for doing this. These are them right here. You are going to see two of these instruments on the plane. We normally only one instrument at a time is mounted in the back of the telescope, but we do have the ability to put this instrument called HIPPO and this instrument called FlightCam on and work at the same time. We actually did that for the very first time last night when we flew the plane up here in the first place. And I actually was not on that flight, which is why I'm not staggering with tiredness right now to talk to you. But I did get the email messages, and apparently it worked quite well for the first time. There's always little bugs whenever you do that, but it generally worked pretty well. Just real quickly, this is our first light. The very first time we actually tried to look at anything in the infrared. We looked at Jupiter. This is what Jupiter looked like in the infrared at these 4 wavelengths up there compared to what you'd find in the visible. And we looked at another galaxy, the core of another galaxy, M82, which is called a starburst galaxy. It's there's tremendous activity of star formation in that galaxy. And here's an area here too. This is our data. You can see the sky is very different if you compare it with what you see in the shorter infrared wavelengths, and of course very different than what you'd see in the visible light with the Hubble Space Telescope. Here's some more recent data. Again, here's our data looking into the center of this area that was seen on the Spitzer Space Telescope. These are a couple other missions here. This is the Digital Sky Survey, which is invisible, and then this MSX was a Air Force mission that was also interested in the background sky. And so these are some data. This is another instrument that we've flown before. It's called GREAT. It's a German instrument. It's basically a very, very fancy, sensitive radio receiver that actually looks at the radio emission from molecules in space. And this is they can actually map areas and certain lines. This is the emission from the carbon monoxide molecule in this area of this nebula called M17, SEA 17. This is, in fact, what you're going to actually see on the airplane right now. This is FlightCam here, like here. Kind of, it's a little bit, in this picture, it's hard to see, but you'll see in the plane, there's a black thing in here. That's the HIPPO instrument. And and so, in fact, this is the configuration that we've got on the plane right now that you'll be seeing. I'm going to skip over these things with actually, I think it's this thing here I'm having trouble syncing. I'm going to talk about another advantage you've got with SOFIA, and that's that it can fly anywhere on the Earth. If you, as it turns out, that one technique that you can use to get good data is to actually take your astronomical object and have it pass in front of a star. And I'll go through this fast here. These shadows of the planets were going in front of the stars only go over a certain place on the Earth, and mostly there's not telescopes there. But of course, with SOFIA, we can fly anywhere in the world, and we've also guaranteed to have clear weather as well. So if you've got the object in the way, and there's a shadow here, and there's only a certain spot of the Earth, we just fly our plane underneath there and do the observations. And in fact, this is one that we observed back in June. This was the planet Pluto and its satellite Charon. And this is a map of the globe. It shows where the that particular. I won't go into this here, but it allows us to see the atmosphere of the planet. And in fact, this is the path of that shadow on the Earth. And this in red here is our flight path. It's actually pretty tricky navigation because this shadow is just zooming across the Earth, going at about 57,000 miles per hour across the Earth. SOFIA can't fly that fast, so you've got to be at exactly the right place at the right time in order to see that shadow as it comes whipping by you. And this is in fact the data. This is the light from the star. It's dipped, and I'll show you a little movie briefly here of the as the star winks out, because as the planet goes across. In fact, this is it here. You can see this is just staring at the star. It's kind of twinkling as the plane is flying. You can see the scintillation, and you'll see it fade out. You actually don't see Pluto. You just see the star going away, and then it'll come back again. This was a group led by Ted Dunham at Lowell Observatory, and using that HIPPO instrument that you're going to be seeing in the plane. Here comes the star back again. And that data that I skipped through before is it helps a lot with understanding Pluto's atmosphere. Although it's very far away and it's very small, Pluto actually does have an atmosphere. And one of the things we're particularly interested in, Pluto, as you may know, has got a very eccentric orbit. So sometimes it's closer to the sun, sometimes it's further away. Right now it's heading away from the sun. We detected an atmosphere in Pluto, but there's some models that show that that atmosphere may freeze out. It may just, and so we were quite curious to see if the atmosphere is still there. As far as we can tell, in fact, it is still there. And so that's one of the first initial results that we actually got using this particular technique. But SOFIA is very good for that, because it's very rare that you'll actually have these shadows going across a place on the Earth where there happens to be a largish telescope, and we can in fact fly SOFIA there as we like, and like I say, with clear weather. Anyway, that's all the time I wanted to spend right now. I apologize for going so rapidly through here. We're a little bit late, but I do know that you want to get on the plane. You've got a group photograph coming up, and you definitely want to get in that before you're in the VIP group ahead of the thundering herd, and you want to get your group shot done before everyone else comes pouring into the tours here. So, does anyone have a brief question before I take you down? Yes.
Yeah. The temperatures are based on color?
Pretty much, yes.
So is it colder, the yellow, or warmer?
This would be warmer. These are cold bands in here. I don't know if you can remember that Jupiter's bands in Great Red Spot kind of come and go. Their atmosphere is quite dynamic, and this area here is a cooler area where the
so that white spot's is one of the spots.
Yeah, except if you actually compare that with in the visible, you actually don't see that. It's not showing up so much like that. So.
Cool.
Yes.
Which instruments have actually flown now?
The GREAT instrument has flown. The Forecast instrument, which is a mid-infrared camera, has flown. The HIPPO instrument has flown. And as of last night, this FlightCam instrument has flown.
Okay,
so we've actually got 4 instruments that have flown. There's some other ones that are still in development. There's a high-resolution infrared spectrograph called Ames. There's a far-infrared photometer called HAWK. And there's another German instrument called FIFI LS that has yet to fly as well. So.